So let's look at some examples of that. This is an area called the hippocampus, where you can see these beautiful brain cells. Well, I think they're beautiful. I don't know what the artists think, but I think they're lovely. Staying 1 in 10, showing these lovely long branches. And the reason I'm suddenly mentioning the hippocampus, you may have heard about it on the news several years ago now, is that it featured in an ingenious study of all people, London taxi drivers. Now, London taxi drivers, as everyone here knows, has to pass the knowledge. That is to say, you can jump in, and they make quite a good fist of this, actually, and you can say, take me from A to B, and usually they can do so without recourse to a manual, and they know all the one-way systems. Now, imagine for a London taxi driver the burden on what's called their working memory compared to the rest of us. They are, every day of their lives, remembering highly complex information and configurations, spatially. And in this ingenious study by Ellen McGuire, a woman scientist, very good, a genius idea, she just scanned the brains of London taxi drivers compared to people of comparable age and found that the hippocampus, this area that's related to memory, was bigger in London taxi drivers than other people. A fact not lost on the London taxi drivers. Most of them have heard of this experiment, actually. So next time you take a cab, ask if they have the hippocampus. And you'll see they all have. And it's not that having a big hippocampus predisposed you to being a London taxi driver, because the difference was more marked the longer they've been driving. So now, many people probably, there are not that many London taxi drivers here, but there are, I'm sure, many people who play the piano, or who kids play the piano. Here's another experiment. This one involved 3 groups of adult human volunteers, none of whom could play the piano. None. And for 5 days, they had the experiment. The control group was always, poor old control group, always get the short straw. They had to stare at a piano for 5 days. Not do very much. The other group had to learn 5-finger piano exercises for 5 days. And the most interesting group was the 3rd group. They had to learn but imagine they were doing it, not actually play. Now, let's look at the brain scans of these 3 groups. And here you can see, let's take the controls first. This is over a 5-day period. Can you see the black blobs show that literally in the control group, the brain was literally unimpressed by staring at the piano, this bit of the brain. However, those learning the piano, look, even after 5 days, so as you've got kids doing 5-finger piano exercises, what's going on in their heads in over 5 days. But look at this is the most remarkable, is merely imagining you're playing the piano has a similar effect. I gather the same is with golf, eh? And with many other things, I'm sure. But the whole idea is, I'm sure there's some nascent philosophers here, who like to draw a distinction between mental and physical. I, as a neuroscientist, would challenge you with that. My own view is that mental versus physical is not very helpful as a distinction. It's actually downright misleading. You don't have some airy-fairy world that, is devoid of the squalor of the kind of world that I live in, but the two do mix very much, and one is related very closely to the other. That everything you're feeling and thinking, however seemingly rarefied and exotic, actually has a grounding in the bump and grind of brain cells. Banal though that sounds, as you can see. So the more you practice, the more your brain, like any part of your body, will respond by getting stronger. So let's ask the question then, as philosophers would, and neuroscientists very rarely do, what is a mind? Well, I'd like to suggest to you this is the mind. You're born with almost your 100 billion neurons. We've seen that the growth of the connections between the cells accounts for the growth of the brain after birth. For people that like numbers, that's about 150 trillion. These connections, as we've seen, reflect experience. And therefore, it is these connections, look at that lovely picture, where you have brain cells, but more importantly, they're connections that gives you your uniqueness. This is what makes you the person you are. It's not just that you have connections and they're fixed, but they are evolving and changing and updating every second or sub-second you're alive. Every experience you're having is modifying the connection, and every experience you're having, you're evaluating in terms of what's happened before. And this iteration, this dialogue, this beautiful dialogue, and exquisite adaptation between you and your environment is the hallmark, it's the birthright of the human brain, par excellence, although other animals do it, par excellence is what we do brilliantly, which is why we are more individual than any other species, I would argue. So, let's look again at the rodents and see what the basis for this is. What is the basis for those increased blobs? Well, here we have again, this time our friends the rats, in an isolated environment versus, again, a so-called enriched environment. We're going to look at a single brain cell from each of these animals. Okay. Now, at first glance, for the non-specialist, this might seem